Okay, let's do some 1D kinematics review. So, in this first question, Luke Skywalker is, let's see, let me get my brushes right, there we go. Luke Skywalker is having a lightsaber duel with Darth Vader, of course, and whoops. Okay, and he falls into a carbon freezing pit, so there's our little pit there. And just before the, freezing gas, the gaseous carbonite or whatever it is about to, freeze him, he sees this exposed cable hanging above his head, and the distance, of course, between his hands and the exposed cable is 5.0 meters. So there we go, 5.0 meters. And he can jump vertically with an initial speed. So I'll go ahead and make that a VI for Luke of 5 meters per second. No, sorry, 5, not 5. Let's see if I can undo that. There we go. 10.0 meters per second. And of course, this problem would not be complete without Darth Vader out here. There's Vader, there's the cape, and of course the red lightsaber. There we go. Okay, so Luke has to jump up and reach these cables. He can jump up with an initial speed of 10 meters per second. Does he reach the cables? So first of all, just to be clear, let's establish our coordinate system. We're going to say the vertical direction up is positive y, which means then Luke's acceleration, let's see, assume the gravity in Cloud City is the same as on the surface of the Earth, so Luke's acceleration will then be, negative g, or negative 9.8 meters per second squared. Simple enough. Okay, so there are a couple ways to solve this. Let's see. One way, and I think I will do this way in blue. One way is to say, look, suppose Luke gets up to the cables. What will be his speed there? And if you want to do it that way, then you're going to do v final squared. Okay, so this is v final squared minus v initial squared. You're going to pull this equation out. 1/2 times that is going to equal your acceleration times your displacement. Okay, so plugging in here, 1/2 whatever Luke's final speed is, or final velocity is, okay, minus his initial velocity, which is 10.0 squared, equals, and then acceleration is negative 9.8 meters per second squared, and the delta y he has to cover is 5.0 meters. And what you'll get is that 1/2 of Vf squared minus 100, because 10.0 squared is 100, is equal to, let's see, right, negative, and this comes out to 49.0, I guess. So, then what you can get is Vf squared minus 100 equals negative 98.0, or Vf squared equals, add 100 to both sides, positive 2.0, which means when Luke gets to the cables, he will still have a speed of square root of this. So Luke's final speed, or final velocity, will be about 1.41 meters per second, give or take. So he will, yes, just barely have enough be able to get up there. Now, what if he had not been going fast enough? So let's just, or the cables have been too high for him to reach starting a jump at this speed. Well, what would have happened there is delta y would have been bigger, right? So if you imagine this 5 was just a little bit bigger, even 6, then this number would be a little bigger. Instead of being negative 49, it would be whatever, negative 50-ish, okay? High 50s, almost 60. And then you would have subtracted or added this 100 to both sides. This would have become over 100. And then you would have come up with Vf squared equals a negative number. And that would be the only solutions for Vf would be imaginary numbers. And in this case, the fact that it's imaginary, it means that, you can only imagine that Luke would make it in that case, because he wouldn't. So that's one way to approach the problem. Another one is to say, look, I'm not gonna assume he makes it, or I'm not gonna set up the equations assuming that he makes it up to the cables there. I'm gonna, let's see, how do I cut. That's not bad. All right, so and cut. Okay, so instead of assuming Luke makes it to the cables, so I'm gonna. There we go. Let's close method 2. We're going to say, look, let's just say Luke jumps up, and when he gets to the peak of his jump, so at peak of the jump, his velocity is going to equal 0. So then we find out, well, how high can he jump? And we can plug in this same equation. We can say Vf squared minus Vi squared, and it's 1/2 of this, equals a delta y. Okay, and once again, yeah, we have everything over there. So we're going to say we don't know what Luke can jump to. Delta y is his maximum jumping height. We don't know that. We're going to figure it out and hope it's more than 5 meters so that Luke can survive. Okay, so 1/2 times, V final would be 0 squared minus 10.0 squared, initial velocity there. Okay, equals, and acceleration is of course negative 9.8, and then delta y is his maximum jumping height. Maybe we can say, y, you can say h is his maximum jumping height and solve for that, I suppose. Just substitute that in for y, whatever makes you happy. So then we got negative 100, which is, let's see, well, I'm doing 2 steps here, so I'm doing the 100, and then I'm going to bring the 2 over. So equals negative 19.6 delta y, and what you get is delta y equals 100 over 19.6, which should come out to be, well, it's going to be it's going to be greater than 5. It's greater than 5.0 meters. Not by much, but it's greater than 5.0 meters, and that's what we needed. Okay, Luke needed to be able to jump up at least 5.0 meters to get there. So that's another way to show that he can do it. Yeah, I mean, those are the 2 sort of most easy to see ways. If you don't remember this equation here, this 1/2 Vf squared minus Vi squared equals a delta y, then you can use the other 2 equations to get there. So, whoops, well, let's see. So let's say we had not remembered this. So we can't remember that, and the downside of this little tablet computer I've got is that I don't have a keyboard handy, so I'm not as fast when I have to go mouse to everything. So then what we could do is we could say, well, so what's the time? Do that every time. What's the time it's going to take for Luke to reach the peak? So we're going to say, let's see, delta V is acceleration times delta t, or you could just say t if you wanted. If you want to say you start at time 0. So delta V final would be 0. So the final minus the initial, which was 10.0, equals, and then acceleration is negative 9.8 because it's gravity, and delta t. And then you get delta t, which is the time that Luke the time that it takes for Luke to reach the peak of his jump would be, well, the negatives are going to cancel, right? 10.0 over 9.8, which is going to be about 1.02 seconds. Okay, and then the question is, how high can Luke get in that period of time? And then what you say is delta y equals v initial times delta t, okay, plus 1/2 a times delta t squared. Okay, and let's see if we can grab just a little tiny bit more space. So then what you get is the height he gets to, I mean, this will be the same result we got before, right? So initially 10.0 meters per second times 1.02 plus 1/2 times negative 9.8 times 1.02, squared. Well, hang on. There we go, squared. And then that gets you, 10.20 meters minus, let's see, it's going to be 4.9 for this times 1.02, so about 4. I mean, minus, probably like 4.9. No, maybe minus 5 point, yeah, minus 5.10 is what it's going to come out to, or close to it. So he's going to reach 5.10 meters up. And then that's the same answer we got by doing it the other way. It just takes a little longer because we take this detour, or we have to find delta t on the way. But you get there and you don't remember the third equation. So if you forget the third equation, that helps. Anyway, that's problem 1.